Good morning, everybody. Welcome to our lesson today of grade 8 and 9 equations. Tapelopitch is my name from Moteo District, subject advisor responsible for grade 8 and 9. Today we are going to deal with equations. And as we said in the past, mathematics is a language from other languages or to other languages. So when you talk about equations, it's an action of equating. Equating, we can say equal, which is a mathematical symbol, is you're equating. When you equate, you form equations. And then the symbols of important there is equal. Let's look at this for an example. We say x plus 5, that particular number. We are equating the expression on the left with the expression on the right, or with the term on the right. And equal means, or equating means, there is a balance. They are equal at any given time. Let's see, for this statement to be true, for the left-hand side to be equal to the right-hand side, your left-hand side to be equal to the right-hand side. For this statement to be true, what do you add 5 to get 10? What do you add 5 to get 10? So it means whatever we are looking for this number. What are we going to add 5 to get number? What is this number here that will make that statement true? And we can see it's a 5 plus a 5 equals to 10, meaning that x stands for 5. X stands for 5. Right. Let's continue furthermore. X plus 3 is equals to 5. What is the value of x? What do you place in that placeholder? What is that value that x stands for? What is that value that we can put in a placeholder that will make this to be balanced? Right? We need to make this balanced. For it to be balanced, in other words, for it to be 5 equals to 5, what do we add there? It's of course our 2, meaning that your x is equals to 2. X equals to 2. Right. One more question of equations. Okay, x plus 4 equals to 9. And always let's be observant, let's try and understand, let's analyze what is actually taking place here. What is actually happening here? We all agree that for this statement to be true, for you to get 9, you have to add the value 5, meaning that your x is 5 plus 4 equals to 9. But let's also look at this. What is the relationship? You know, mathematics is a subject of relationships, numbers with symbols, letters, variables. But Are we picking any pattern here of some sort? Are we picking any pattern of some sort? Let's try another one and see whether we are picking pattern of some sort. X plus 5 equals to 15. What do you add 5 to get 15? You add it to 10. And that statement is true. 10 plus 5 is 15. Therefore, there is always that balance. But again, let's look at the relationship. Let's look at that relationship. What is the difference between 9 and 4? What is the difference between 9 and 4? It's a 5. What is the difference between 5 and 15? It's a 10. The difference. So let's look at that pattern. The difference. The difference. What is the difference between 15 and 5? It's a 10. How do they differ? 10 more. This is 10 more than 5. This is 10 more than 5. There is that difference. Right. And remember, we agreed here, therefore, x we agree is equals to 10. But let's check. What happened to that 5? This 5. Remember, the initial equation was x plus 5 equals to 15. Now the question is, what happened to this 5? What happened to the 15? To get here, to get there, what do you think has happened? In other words, we can effectively say x plus 0 equals to 10. Which means x plus 0, x is equals to 10. So it tells me, I hope you too, that you subtracted that 5. You removed that 5 mathematically by using what is called an additive inverse. In other words, our original equation says x plus 5. Now, we remove this 5 mathematically. Right? So that 5 was removed there mathematically. So from 15 to 10, what did you do? Same thing. From 5 to get 0, you removed 5. From 15 to get 10, you removed 5. Meaning 15 minus 5. Remember, because an equation is an equality, it works like a scale. A scale, you don't want a scale that is tilted. It's not fair. It must always be balanced. If from a scale you take something out here, it's going to tilt this way, you must quickly take so that they can balance. That's what we have done effectively. That's what we have done effectively. Meaning x, 5 minus 5 is 0, 15 minus 5 is a 10 to get the value of x. To get the value of x. Let's check once more. Another question. We all agree x plus 10 same question comes to mind. For this statement to be true, what do you do to 10 to get 30? In other words, what's the relationship between 30 and 10? You add this number to get 30. But what is that number? We all agree is 20. Then the statement is very true, very correct. But again, remember, what is that relationship? What is happening here? What is the relationship between 30 and 10? What is the difference between 30 and 10? It's 20. What is the difference between 30 and 10? It's 20. But we said, meaning your x is equals to 20. But from 10 to 0, from 30 to 10, what happened? From 10 to 0, from 30 to 20, what happened? You see here, 10 was reduced, removed, subtracted mathematically subtracted. 10 was subtracted. So we are saying, effectively, this is what happens. X plus 10 minus 10 to give you 0. 30 minus 10. So let's remember that the rule of fairness. What you do on the left, you also do on the right. What you do on the left, you also do on the right. So that's how we make sure, or that's how we show or prove that x, or finding the value of x. In other words, what is that value of x? That's how we go about it. X plus 10 minus 10 is your 0. 30 minus 10 is 20. So we have shown, we know from here x is 20. Now you are showing us x is 20. We also seen how it comes about. Bear that in mind. Put that in mind. Okay? Let's go further now. Let's go further and talk equations. Equations. Equality. Left equals to right. Now, your operations are in operation. Your operations are used. Again, let's look at the relationship. For starters, for you to get minus 5, you've got minus 4. You've got negative 4. For you to get negative 5, you need to add negative 1 to get you negative 5. All right, again, what is the difference between negative 4 and negative 5? Negative 4 subtract negative 5. What is the difference? What is the difference between 10 and 5? It's a 5. So how is negative 4 different from negative 5? How is it negative 4? How do they differ? What is the difference? Difference, remember, mathematically represents subtraction. Difference, you're operating your removal. Therefore, let's also remember negative multiplied by negative is a positive. Therefore, negative 4 plus 5 equals to 1. That is the difference. In other words, we are going to say, okay, where there is a x, our value is 1. Our value is 1. Negative 4 minus x equals to negative 1. Meaning, negative 4, when you remove my bracket, negative 1 equals to negative 5. Remember that. Now let's see, what do we need to do? What is that value of x? Let's see now. Remember, we need to use an additive inverse to give this value to be 0. Negative 4, additive inverse, what gives it a 0? Negative 4 and a 4, it's a 0. But let's not forget the rules. What do you do on the right? You also do on the left. I mean, on the left, you also do on the right. You have added 4, fairness. You've added 4 on the left, you must also add 4 on the right. Again, your operations are in practice. Negative 4, what's the difference between negative 4 and 4? It's 0. Therefore, we've got negative x equals to negative 1. Negative x. But remember, we want to know the value of x. Negative x means negative 1 by x. Negative 1 means negative 1 by 1. Now we are looking for the value of x. Right? We want to know the value of x. Now we need to mathematically remove negative 1 by using what is called multiplicative inverse. You multiply. Remember an inverse. Let's quickly remind ourselves, what do you mean by inverse? Let's quickly remind. Inverse of 12 is that number that you'll multiply 2 with, half with, to give you 1. Inverse of negative, what are you going to multiply this number with to give you positive 1? That's your multiplicative inverse, this one. This number that will give you 1. How many 3s into 3? 1. How many 3s into 3? 1. So negative 1 multiplied by negative 1 give you positive 1. How many 2s into 2? 1. How many 2s into 2? They give you 1. So that is called what is called a multiplicative inverse. If you want to see negative 3, what do you multiply negative 3 with to get your positive 1? You are going to multiply it with negative 1 over 3. That's what is called a multiplicative inverse. Now it's 3 into 3. How many 3s into 3? 1. How many 3s into 3? 1. Negative 1 divided by negative 1 will give you 1. Remember that when you want to find out the value of x, it's either we use additive or multiplicative inverse. Now we are coming here now. So to get a positive 1, you are going to multiply negative 1 by negative 1. Multiply by negative 1. Remember what you do on the left, you also do on the right. Right? Therefore, negative 1 by negative 1 is positive 1 by x is your x. That's what we're looking for. We want to know the value of x. Right? Your operations in operation. Negative 1 multiplied by 1 is a negative 1. Negative 1 multiplied by negative 1 is positive 1. Therefore, what is your value of x? 1. Where there is x, you put 1. Where there is x, you put 1. So what is the value of x? Is 1. That's when we want to say, what is the value of x? Or they can say mathematically now, when we get into mathematics now, they say solve for x. What does x stands for? Solve for x. To make that statement true, what is x standing for? Again, let's look at this one. For this statement to be true, what number are you going to divide 6 with to give you 2? That number that you divide 6 with to give you 2. What do you put there to give you 2? Yes, we all agree it's a 12. So we agree, okay, 12 over 6 divided by 6 means what? All right. How many 6 into 6? 1. How many 6 into 12? 2. Therefore, it's 2. Meaning your x is equals to 2. But convince us. When you solve for x, you must convince us mathematically. Prove. Convince us. Show us that x is equals to 12. Show us that x is equals to 12. Or prove x is equals to, x is equals to 12. In other words, show us that x is 12 or solve for x. Remember what we said. We are looking for the value of x. Therefore, how do we make this 6 to be equals to 1? What do we do to 6 so that we have to 1? Correct your multiplicative inverse. Multiplicative inverse. In other words, to get 1, what do you multiply 1/6 with? With a 6. With a 6, that's what we're looking for. So we say, okay, how many 6 into 6? 1. How many 6 into 6? 1. So 1 multiplied by 1, it's a 1. 1 multiplied by 1, it's a 1. Therefore, our multiplicative inverse is a 6. Therefore, it's a 6 multiply x divided by 6 equals to 2. Remember, what you do on the left, you must do on the right. It must be fair. What you do on the left, you do on the right. Multiply by 6 on the left, you also multiply by 6 on the right. Now, how many 6 into 6? 1. How many 6 into 6? 1. Meaning that your left-hand side is equals to x. And then what is 2 multiplied by 6? 12. So you've shown us that x is 12. You've shown us that x is 12. We're looking for the value of x. Sorry there. Here we're just showing you 12 over 6. How many 6 into 12? There are 2 of them. That is not the value of x. So you have shown us that x is 12. That 12 divided by 6 gives you 2. So you are solving for x. That's when you say solve for x. Remember that one. All right, let's do more questions. Let's do more questions. All right. Same understanding, same approach, same rules. Say, okay, 2x divided by 5 equals to 10. So, same approach. That number that you're going to divide 5 with to get 10. What is the, remember this is a single term. This means 2 multiplied by x. So what is that number that you're going to divide 5 with to give you 10? You all agree? Okay, we seem to agree. We say, when you divide, 50 divided by 5 is going to give you 10. So you are saying to me, okay. You are saying to us, 50 divided by 5 is a number. How many 5s into 5s? 1. How many 5s into 5s? 1. How many 5s into 0? 0. So it's a 10. You are saying that number on top. That term, the numerator in this case, is equals to 50. You are saying to us 2x equals to 50. But remember the question was saying solve for x. Solve for x. In other words, you can also look at it. What are you going to multiply 2 with to get 50? What? Remember 2x means 2 multiplied by x. Don't forget that. And when you multiply, when you divide, you're talking about one term. So the question is, what are you going to multiply 2 with to get 15? And again, don't forget the relationships of 2 and 15. Right. That's what that question is saying. And we all agree you are going to multiply 2 with 25 to get 50. And look at that relationship. We agree. In other words, you agree that x is equals to 25. We agree x is equals to 25. But we are saying, show us. Prove to us. Solve for x. Show that that is true. Remember we said we want the coefficient to be 1. We want this coefficient 2 to be 1. What do? Multiplicative inverse, which means 1 over that coefficient multiply 2x. What do you do on the left? Please remember to do on the right. It's an equation, it's a scale. The scale must be balanced. The scale, that's an equation. Equality, fairness. Right? Then we apply our mathematics. Right? How many 2's into 2? 1. How many 2's into 2? 1. Therefore, 1 by x is your x. How many 2's into 2? 1. How many 2's into 5? 2 leaves 1. And how many 2's into 10? 5. Therefore, 1 by 25. Therefore, you have shown us. You have shown us You solved for x. You've shown us you've solved for x. You've shown us, and then you solve for x. But look at it, you must understand first, what is it saying? What is it telling you? Remember, this is a single term. It's always important to know and understand where are you from and where we are going. Where are you from and where we are going. Let's take it to another level now. Let's take it to another level. Let's take it to another level. Our understanding. What is that value of x? This will make this statement true. What is that value of x which will make this statement true? Remember, let's see where we come from. Let's see where we come from. Let's see that root. Here, we ended up with x. We want x, the variable on the left, and your constants on the right. That's what you do. Your variable on the left and your constants on the right. That's the approach. Variable on the left, constant on the right. Variable on the left, constant on the right. That is the approach. That's how we approach. Variable on the left, variable on the left, constant on the right. So that should be our approach. That's how we are going to approach things now. Let's see. That's how we are going to approach it. Right. And remember, we are not doing magic. No. In other words, we are going to get this to be 0, you need to use the additive inverse. Therefore, we say, okay, 4x equals to 3x. You want this to be 0 minus 3x. And we leave minus 9 as is. But now the scale is going to go to the right. Because, therefore, on you do on the right, you also do on the left. That's what we mean. Therefore, 4x minus 3x. What is the difference between this one and this one? For this one to be equals to this one, it needs 1, which means it's x equals to minus 9. Meaning your x is equals to minus 9. Right? That is the situation. Maybe let's also prove it. Let's see, it's always important to check whether what you're doing is right. In other words, where there is x, you put minus 9. 4 multiplied by minus 9. Is this true? Let's see whether this is true. Let's also prove it. 4 multiplied by minus 9 is minus 36. 3 multiplied by minus 9, minus 27. Minus 9, which is true. Which is true. Our value fx is minus 9. Our value of x is minus 9. Right? Let's take another question now. Let's take another question. Question says, solve for x. Solve for x. What is that x standing for? What is in that x that will make this statement correct and true? Remember our understanding now. We want to put our variables on the left, our constant on the right. Same approach. You want an additive inverse of 7. But remember what you do on the right, on the left, you also do on the right. Negative 7 plus 3 minus x plus 4. Then that gives you 0 is 2x. Negative 7 plus 3 is negative 4. And then it's negative 4 minus x plus 4. Right? What is the situation? Let's see whether 2x plus 7 equals to 3, x minus 4. Additive inverse to give us 0. Add here, negative 4, negative x plus 4, meaning that 2x equals to negative 4 plus 4, it's a 0, which is negative x. All right? Then we set everything that is a variable, we take it to the left, equals to 0, therefore 3x equals to 0. Again, we want that multiplicative inverse, which is 1 over 3 by 3x, and then what you do on the left, you do on the right. Okay? What you do on the left, you do on the right. Again, how many 3's into 3? 1. How many 3's into 3? 1. And then it's an x. Everything multiplied by 0 gives you 0. Therefore, here we say the value of x is 0. Let's see how true this is. It's important to always prove yourself. If you say the value of x is 0, you say, okay, where there is x, I put 0. Where there is x, I put 0. 2 by 0 is 0, that is 7. 3 plus 4 is 7. That is how we solve for x. Also prove. But it's important to look at the equation generally. Now let's take our equations to fractions. Let's take our equations now to fractions. We need to practice more fractions. Sometimes it's not given, it's not a single step, or to get an answer by expression, like we say, oh, okay, x plus 5 is 25. We say, okay, what's the difference here? It's 20, therefore, what do you need to add? 5 to get 25, it's a 20, therefore x is equals to 20, or prove it to us. We want to move that one. You still remember 5 minus 5 equals 25 minus 5, therefore x is equals to 20. Some are as straightforward as that, but some not necessarily. Let's see such. You want to have more work on our fractions. Like terms, therefore you can subtract or add. The terms are like is 1x over 4 minus 2x over 3. So it's like ordinary fractions. Maybe a quick reminder. Let's remind ourselves of what do we do when we deal with fractions. Remember our LCM, lowest common denominator or lowest common multiple. We want the base to be the same. Denominator is 4, denominator is 3. You want common denominator. Therefore, what we'll normally do if these are not factors to each other, we multiply each by the other denominator. We use that denominator 3 over 3 because remember 3 over 3 effectively means 1. Anything multiplied by 1 does not change the number. Same thing here, we'll say minus 2 over 3 multiplied by that denominator, which is 4 over 4. Because you want this to be common. Or you can just say your LCD or LCM is 12. Therefore, 1 by 3 is 3 over 12 minus 8 over 12. So they've got a common base. We can say 3 minus 8 over 12, which is going to give you minus 5 over 12. So it will be the same things with your fractions. Same things with your fraction. With your expression, same approach. Same approach, very same approach. The denominators are not the same, they are not factors. So you can see 4 by 12 by 3 is a 12. But how do we set mathematically? Let's use the denominator of the other, which is a 3. Therefore, we say 3 over 3 minus 2x over 3 by using this one. 4 over 4 equals to 5. Right? 3 multiplied by x, 3x over 12. Minus 8x over 12 equals to 5. Equals to 5. There is our base, common. The foundation is common. Therefore, we say 3x minus 8x over 12 equals to 5. (3x over x), 3x minus 8x over 12 equals to 5. Therefore, because they've got a common base, you would say minus 5x over 12 equals to 5. Two ways. Two ways. Two ways. Let's look at it. What is that number you're going to multiply 12 with to give you 5? What is that number? Which is a 16. Or, again, we want to deal with coefficient. Remember, we are solving for x. What is the coefficient? Minus 5 over 12. What do you multiply if to give you positive 1? What do you multiply if to give you positive 1? You're going to multiply it with the inverse or multiplicative inverse, which is negative 12 over 5. But what you do on the left, you also do on the right. What you do on the left, you also do on the right. So how many 12s into 12 is 1? How many 12s into 12 is 1? How many 5s into 5 is 1? How many 5s into 5 1? Negative 1 by negative 1 is positive 1. 1 by 1. Therefore, this is your x. Remember, we want the value of x, or we must show out that what the x value is, or we must solve for x. Right? How many 5s into 5 is 1? How many 5s into 5 is 1? Therefore, minus 12 by 1 is negative 12. That is negative 12. And when you go here, let's go here. In other words, we have just shown that x is equal to negative 12. How true is that? Let's see whether that is true. In other words, okay, minus 5, where there is 12, where there is x, we put negative 12 over 12. Is it equals to 5? Let's see what happens. Or when you look at it, minus 5 by minus 12 is equals to 60 over 12. And how many 12s into 60? 5. Or how many 12s into 12s? 1. How many 12s into 12? 1. So negative 1 by negative 5 by negative 1 gives you 12, gives you 5. Or how many 12s into 12s? 1. How many 12s into 65? Same approach. What you do on the left, it's an equation. We equate them must always equal fairness. That's what we do here. And then the rules and the laws will always apply. The rules and the laws will always apply. The rules, BODMAS is into the picture. When you deal with fractions, it's also into the picture. Let's try this one. 3p minus p over 4 should give you 11. Now we're going to look for that value. Show us what value will make the value of p will give us 11. Is it 30 minus 19? Or 18 minus 11? This one is not straight and forward. Therefore, you want the foundation. It's a fraction. It's a p4 and 3p. Now we need that lowest common denominator, which looks like a 4 here. That one must also be having a LCM of 4. Therefore, we are going to say, okay, 3p multiplied by 4 over 4, which is effective equals to 1, minus p over 4 equals to 11. Remember, 4 over 4 means 1. Therefore, it's still the same. Effectively, nothing has changed. But now we are looking for the foundation, your denominator. The base must be the same. The foundation denominator must be the same, which is a 4. Therefore, 3p by 4 is 12p over 4 minus p over 4 equals to 11. So the foundation the same. Therefore, we can say, okay, 12p minus p of all over 4 equals to 11. Equals to 11. Like terms, how are they different? What is the difference? 11p over 4 equals to 11. Multiplicative inverse, what is the coefficient here? What is your coefficient? Your coefficient is 11 over 4. And then how do you make, using multiplicative inverse, that equals to 1 by using the inverse, which is 4 over 11 multiplied by your coefficient. But what you do on the left must also be done on the right. It must also be done on the right. It must also be done on the right. How many 11s into 11s? 1. How many 11s into 11s? 1. How many 4s into 4s? 1. How many 4s into 4s? 1. 1 by 1. It's a p. Remember, show us the value of p. Show us, solve for p. Mathematically convince us what p is equals to. Right. Therefore, how many 11s into 11s? 1. How many 11s into 11s? 1. Therefore, p is equals to 4. P is equals to 4. Now, of course, let's go back and prove that P is equals to 4. Our original equation says 3 minus P of 4 equals to 11. 11, sorry. Therefore, let's see. Where there is P, let's put 4. Where there is P, let's put 4. 3 multiplied by 4 minus 4 over 4. Is it going to be equals to 11? Is it going to be equals to 11? Where there is P, let's see. Right? Your bottommost, you remove the bracket. Start with the brackets. 3 multiplied by 4 is a 12. 4 over 4 is a 1, it's a negative 1. And of course, 12 minus 1 is equals to 11. So that is when they say solve for P, show us what is that value that will make that statement is true. Equations, that's how we're dealing with our equations. We are dealing with our equations. Let's have more practice, because we want to, when you look at the videos, take time. Fast forward, go back, reverse, rewind where you don't understand, look at it, have more examples. Here we are doing expressions in fractions. We are working with our fractions now. We are working with our fractions. The next question, 3a over 10 minus 2a in fifth equals to a plus 2, a over 2 plus 3, I'm sorry. It's not straightforward. We cannot do it by inspection. What is the value of a? Now we must find out the value of a. Remember, any term or expression with variables come to the left. Any constant go to the right. Step number 1. And what is important in mathematics is the step-by-step process. Build a house, draw a plan, foundation, the walls, the windows, the roof. It's a step-by-step. So what is important? Number 1, you take variables. You want variables all to be on the left hand side. And remember, how do we do that? 3a over 10 minus 2a divided by 5. Now, we want 0 here, we remove it. We are going to use additive inverse. In other words, to get 0 here, you add it to the value equals to it. But now don't forget, what you do on the left, you also do on the right. Equation. Mathematics is a step-by-step process. That's what matters. And then for that effort, you will be given a reward. That one step you've done, you'll get your 1 mark. 3a over 10 minus 2a over 5 minus a over 2. And you know this and this additive inverse is a 0, therefore we are left with 3. We have succeeded doing that now. The next step now is fractions. 5 is a factor of 10. Therefore, we can use the LCM of 10. 2 is a factor of 10. Therefore, we can use an LCM of 10 or LCD of 10. So we want these denominators to be equals to 10. We want everything here, denominator, to be equals to 10. Right? Remember, that's what we do in fractions. All right? 3a over 10, that is sorted. Minus 2a, how do we make that 5 a 10? How do you make that 5 a 10? You multiply it by 2. But remember what you do. You want it to be 1. 2 over 2 is 1. Because 1 means this thing is not changing. Right? Good. Minus a over 2. Now we want to make it 10. Meaning what? We multiply it by 5 over 5. Because we want to be 10 and all equals to 3. Right? Now we've got your 3a divided by 10 minus 2a by 2 is minus 4a divided by 10. The base is the same now. Minus a by 5, 5a over 10 equals to 3. Now we've got our commonality. It's an a there because now it looks like a 9, but it's an a. Commonality, the base now. The foundation has been laid. The denominator is a 10. We are happy with that. Now we can do our mathematics. 3a minus 4a minus 5a, everything over 10 equals to 3. Mathematics is step by step. You'll get a 1 mark for that. For your LCM, for every effort, you'll get a mark. Therefore, it's a step-by-step process. Don't just look at the final answer. You have to get it step by step so that we can see. There we are now. We are there. We've got our lowest common denominator. 3 minus 4a is minus 1a, minus 1a and minus 5a is minus 6a all over 10 equals to 3. Do you remember now? We are looking for a. We are not looking for negative a. We want to know what is the value of that a. In other words, we look at the coefficient so that we multiply the coefficient with multiplicative inverse to give us positive 1. Right? What is your coefficient? Minus 10 over 6. That's your coefficient. Therefore, we multiply this one by minus 10 over 6. Sorry. Your coefficient is minus 6 over 10. So you're going to multiply it with the inverse to give us 1, positive 1, which is minus 10 over. Whatever you do on the left, don't forget to do on the right. Again, apply our mathematics. How many 6s into 6? 1. How many 6 into 6? 1. How many 10s into 10s? 1. How many 10s into 10s? 1. Negative 1 by negative 1, positive 1 divided by 1. Therefore, you've got your 1a, which is the same as a. Same as a. Right? How many 3s into 2? Or how many 2s into 6? 3. How many 2s into 10? 5. How many 3s into 3? 1. How many 3s into 3? 1. Therefore, 1 by negative 5 is negative 5. Your a is negative 5. Your a is negative 5. Are we on the right track? Are we on the right track? Let's see. We say a is negative 5. Let's see. 3 into negative 5. Where there is a, you put negative 5. 2, where there is a, you put negative 5. Negative 5 over 2 plus 3. Right? Let's see the situation here. Let's see the situation. Both must remove the bracket. 3 multiplied by minus 5 is minus 15 over 10. Negative 2 by negative 5 is 10 over 5. Right? Let's see here. Okay, let's go to the next page. Let's see whether we do it everything like 3 by minus 5 is minus 15. Minus 2 by minus 5 is positive 10. Minus, okay, on the right track. Let's see what we get here. Minus 15, how many? Okay, let's rewrite it and look at it slowly. How many 5s into 10 into 15? 3. How many 5s into this one? 2. Therefore, it's negative 3 over 2. We want to see whether it will be equals to this one. Right? How many 5s into 5? 1. How many 5s into 10? 2 plus 2. Now let's see whether they're the same. Let's look at our fractions. Let's look whether we made a mistake or what. It's not clearly that they're equal, but let's see nevertheless. Minus 3 over 2. We're looking for a common thing. So, okay, 2 over 2 multiplied by 2. Same thing here, minus 5 over 2 plus 2 over 2 multiplied by 3. Let's see whether we'll get the same thing. Minus 3 over 2 plus 4 over 2 equals to minus 5 over 2 plus 6 over 2. Right? Minus 3 plus 4 over 2 equals to minus 5 plus 6 over 2. We want to see whether we'll get the same. So what is the difference between negative 3 and 4? It's a 1 over 2. What is the difference between negative 5 and 6? It's 1 over 2. Therefore, we were correct. That kind of practice gives you an opportunity of practicing more mathematics. Applying the rules. Please look at the equations, look at the fractions, how they are done. Practice more over and over again. I hope you enjoyed today's lessons. It's making your fractions and your equations more understandable and give you a better approach. Good luck for the term. Thank you very much.